Hello, my name is Sudara. I'm going to talk about how we can improve the sort function we use in our organization. Our employees use the sort function for various data with different input sizes. The sort function works with the bubble sort algorithm, but if we change our sort function to the merge sort algorithm, sorting data can be done much faster. This is because the runtime of bubble sort has a big O of n squared, while merge sort runs at time complexity of n log n. Let me elaborate. Time complexities help us understand about the runtimes of algorithms. They're usually given in big O notation. Big O notation represents the asymptotic upper bounds of functions. In this case, the time function of each algorithm. So a function with a higher asymptotic upper bound will perform much worse than a function with a lower upper bound. So here, n squared has a higher order than n log n. So a function running n log n will perform much better at less time for a given input size beyond a constant k. If we compare time complexities with a given input size, it'll help us further understand why time complexities matter when we choose our algorithm. So at an input size of 1, they all perform equally well. At an input size of 16, n log n algorithms already perform much faster than quadratic and cubic algorithms. At an input size of 1024, n log n algorithms have an order of 5 compared to quadratic algorithms, which have an order of 7, which means they're at least 100 times faster. So n log n algorithms like merge sort, they're much faster than unsquared algorithms like bubble sort. This is how bubble sort works. This visualization shows that in bubble sort, elements are swapped until the biggest element goes to the end of the array. This continues. The swaps are based on which element is bigger, and the bigger one is shifted towards the right. As you can see here, there are two for loops. The outer for loop runs n times, and the inner for loop runs n minus I times. So that gives an n squared runtime. Merge sort, on the other hand, uses a divide and conquer strategy. So each array is divided into two partitions which are equal or almost equal. This partitioning is done continuously, recursively, until there can be no more partitions. After this stage, these partitions are merged together, and while they're merged, they're sorted in order. So this simplifies the task by breaking them down into lower chunks which can be handled much faster. So the height of the tree when you partition the arrays has a height of log n, and the merging operation takes n time. So thus it gives an n log n time. Here is the pseudocode for the algorithm. As you can see, it's partitioned in the middle, and they're sorted left and right, and they're merged before the list is returned. In summary, bubble sort takes n squared time complexity, merge sort takes n log n. Because of these reasons, bubble sort is less efficient than merge sort because it takes more system resources as it takes more operations to complete the sorting task, and also bubble sort has low speed because it has to do a lot more operations, and merge sort can go much faster by divide and conquer. Also, bubble sort can only take a small input size. If it grows bigger, the runtime will be much larger, and that will not be viable for certain solutions. Merge sort, on the other hand, can handle large inputs and can do it without putting much strain on the system. Thank you for listening. I hope we make the change from Bulbasaur to Mersaur.